So good evening. So for this video presentation is for the feedback and control system lecture for the week 8 homework. So for starters, so for the questionnaire number 1 will be discussed by Mr. Labio.
Okay, so in week 8 homework, number one item. So the question is why, in spite of the ability of computational software to solve the rules of high order transfer functions, the Routh-Hurwitz criterion is still an effective mathematical tool to determine the stability of the systems. So, tinatanong kung effective pa rin ba yung Routh-Hurwitz para malaman yung stability ng system. So, my answer is yes, it is still an effective mathematical tool to determine the stability of the system. But, the stability is very important for the system. Kasi, therefore, so the analysis should be performed with high accuracy. So, by using computational softwares, we obtain the absolute, relative, and conditional stability. So we perform this by just entering the coefficients and get the output easily and quickly. So lastly, we obtain different solutions, numerical, symbolic, and graphical results. So unlike in conventional solving of Routh-Hurwitz, so sa paggagamit tayo ng computational software, meron siyang mga graphical results. So, yun yung sa akin.
Well, also kasi sa Routh-Hurwitz stability criterion, if any control system doesn't satisfy the necessary condition dun sa given, hindi magiging stable yung control system. Which is kaya lagi nating, hindi naman lagi, kumbaga, ginagamit natin mas accurate kasi ang Routh-Hurwitz stability criterion. Kasi if ever na hindi masasatisfy yung system, hindi natin magagamit yung computation na yun. Kumbaga, for stability talaga siya. Yun yung half na answer ko sa number 1.
So for number 1, ang advantage din na Routh-Hurwitz criterion is that we can find the stability of the system without solving the actual equation. So mani-determine natin kung relative stability of the system. So using Routh method, madi-determine natin yung RHP and LHP, which is RHP means right half plane and LHP is for left half plane.
Okay.
So for the questionnaire number 2, will be discussed by Miss Jamay Abukay.
Number 2, state the closed-loop pole distribution in the S-plane of a system whose route table is shown below. Note that this route table is under one of two special cases. Dito sa number 2, yung ginawa ko is, di ba meron ng given na route table? Inano ko na lang yung sa even tsaka others. Tapos sa even, binilang doon kung ilan yung sign changes. Tapos, syempre, alam naman na kung ilan yung sign changes, yun din yung equal siya sa right half plane. Kung ilan yung poles sa right half plane. Tapos sa others naman, walang change. So, ang magiging yung poles doon ay mapupunta sa left half plane. Tapos sa even kasi dapat equal yung number ng poles ng right half plane tsaka left half plane. So kung 1 yung sa right half plane, dapat sa left half plane 1 din. Tapos yung natitirang poles doon ay mapupunta siya sa J omega axis. Ayun lang.
Same goes dun sa sorry. So, doon lang kasi, tama naman yung ginawa ni Miss Abukay. Bali, ako din, ganun din, nilagay ko din yung, since given naman kasi yung table, So, sinegregate ko na lang kung ano yung mga kailangan na values. Tapos, which is, nag-end up na rin ako sa left half plane, right half plane, tapos dun sa even, tsaka other numbers, tsaka dun sa total.
So question lang. So, paano natin na-determine kung stable yung system using the route method dun sa table?
Wait lang.
Siguro, sorry.
Sige, Jo, ikaw na.
I'm sorry, ulit nga yung tanong.
Okay, yung question is, how can we tell if it's stable system based on the route table?
Since ang stable systems have di ba may mga closed loop transfer function with poles, di ba only in the left half of the plane, dun nakikita kung stable yung system. Dun sa
Okay.
closed loop transfer function.
Okay. So, sa akin naman, how can we tell if the system is stable? Tama ba yung tanong?
Marginally stable.
Okay. So, stable siya kasi stable systems have closed loop transfer functions with poles only in the left half of the S-plane or the LHP.
So question, for the second question lang. So paano natin malalaman if it's marginally stable system? So guys, sino gusto mo mag-answer? So repeat ko yung question. How to tell if it's marginally stable system?
Kapag walang sign change lalo na kung nandun sa even, wala siyang sign changes. So, wala rin sa right half plane, wala rin sa left half plane. Nasa imaginary axis lahat ng routes.
Tama. Oo, tama. Just sa imaginary axis.
Thank you for answering, Ms. Abukay. So for the questionnaire number 3, will be discussed by Jonar Christian Rojas.
Sorry. Okay, wait. Teka lang. Sorry. Pa-zoom. Okay, number 3. Given the closed loop transfer function of the system as TS is equals to so given na nakikita naman natin yung transfer transfer closed loop transfer function, determine how many closed loop poles lie in the right half plane, in the left half plane, and on the axis. So yun nga, bale ang ginawa ko is so since binigyan tayo ng transfer function, so nilista ko yung characteristic equation. Pero bago ko nilista yung characteristic equation, sinolve ko muna yung transfer function. Tapos after kong malista yung characteristic equation, inano ko na din yung characteristic sequence nila, which is yung ang pinakamataas kasi niya na higher power is yung S5 up to S0. Tapos nilista ko yung halimutan ko yung tawag, sorry. Nilista ko yung number which is indicated sa transfer function, then solving for each row, which is parang determinants kasi ang pagsosolve ng numbers diyan eh. Tapos obtaining a values of LHP, RHP, and JW and total of even numbers and others and total. Bale, yun yung process ko para pa labasin yung mga values na to.
Tas ano pa, yung
So,
dito din
for
sa
question.
tas yung dito din sa number 3, yung dun sa may S3, yung sa power ng 3, naka-encounter tayo dun ng yung mag-zero yung first column, tas yung sa second column. Tas yung ginawa ko para magkaroon siya ng value is, kinuha ko yung derivative nung naunang column, yung naunang row, para makuha ko yung magiging value ko para dun sa S3, para hindi na siya mag-zero. Tapos, dun ko sisimulan yung sa even niya, papunta sa S0, tas yung others. Simula dun sa high power hanggang dun sa kung saan ako kumuha ng derivative.
Okay.
Ayun.
So,
for number,
question?
ikaw nga. Wait, please lang. Wait lang. Okay.
Sige.
So for number 3, given the closed loop transfer function of the system, P of S is equals to S cubed plus 2S squared plus 7S plus 21 over S raised to the fifth minus 2S squared plus 3S cubed minus 6S squared plus 2S minus 4. So given the transfer function, gumawa kami ng route table, which is nakikita dyan sa screen. So from S5 to S0. So from yung given na poles na yung denominator is yung values niya, nilagay namin sa route table, which is yung 1 for the S5, then 2 for 2S4, then 3 for the 3S cube. Then sa S4 na row is negative 6. Then for the S5 row is yung 2S. Then for the S4 is yung negative 4. So, paano namin sinolve is that is parang pa-cross yung multiplication niya. So, from negative 2 times 3 minus 1 times negative 6 over negative 2. So, equal siya sa 0 and so on. So, ganun namin nakuha yung
Table.
pagkuha ng RHP and LHP.
So, ganun din sa akin. Same lang din. So, kukunin mo muna yung matrix ng mga coefficients. Tapos, get the determinants. Then, you have to divide dun sa may pinaka-lower bottom left na value. So, ganun din lang siya. Cross multiplication ng dalawa. So, ganun din. 1 times negative 6 minus 3 times negative 2. So, all over negative 2. So, ang lalabas is 0. So, ganun lang namin siya kinuha yung value. Okay, so, questions?
Yes, may questions ba?
Ako
na magtatanong.
Ako na lang magtatanong.
Okay, go.
Okay, so, my question is, how can we tell if it's marginally stable system?
Gaya nga nung sinabi ni Miss Abukay kanina, yung sa roots of the system, maglalay siya sa S-plane para
Nasa
maging
imaginary
state.
So, paano natin ma-determine kapag LHP, guys?
Pag
If there's LHP.
Sorry?
How do we LHP?
Yung dito sa, di ba sa even makikita natin na dapat kung ilan yung sign changes, yun yung sa RHP. Tapos kung ilan yung RHP sa even, yun din yung sa magiging value ng LHP sa even. Kasi dapat equal sila palagi. So dito, nagkaroon ng 2 beses na sign changes. Kaya naging value ng RHP dito is 2. Tapos naging value din ng LHP sa even is 2. Kasi dapat same sila. Tapos sa others, nagkaroon ng 1 change. di naging napunta yung pole na yon napunta sa RHP. Kasi dito makikita natin na dapat ang magiging total ng lahat ng poles is 5 lang. Sa even, nagkaroon na ng 4 poles. Kaya dapat magiging 1 na lang yun dun sa others. Ganun.
Okay. Thank you for answering, Ms. Abukay. So for the question number 4, so let's proceed, guys.
Okay.
So I'll be answering the number 4. So determine whether the unity feedback system whose forward transfer function is g of s is equals to 240 over s plus 1 times s plus 2 times s plus 3 times s plus 4. So given yung poles is that naka-factored form siya. Since naka-factored form siya, is one of the condition of Rhodes-Hurwitz criterion is that yung denominator is dapat naka-polynomial form which is naka ganito yun sa screen. Pwede ka zoom in.
Can you show your
Yes,
answer? May answer ka?
Nandyan po.
Nandiyan. Dito ba?
Number
Sa
4.
number 4.
Sa number
Number
4.
Bakit? Ayun.
Ayan. Pataas po. Ayan.
Yeah.
So,
Okay
ayan.
na.
So since
So,
naka-factored form siya na s plus 1 plus s plus 2, s plus 3, s plus 4. So ang condition for Rhodes-Hurwitz criterion is that kailangan natin siyang polynomial form which is magiging s raised to 4 plus 10s cubed plus 3s squared plus 50s plus 5s, plus 24. So, gumamit kami ng route table for solving this transfer function. So, yung same process lang like before. So, yung routes are imaginary axis. So, based on the question kanina, since na yung routes are on imaginary axis, so marginally stable siya. Yun lang.
Yeah, same. Yun din sagot ko eh.
May question.
Mm. Yes, ano po yun?
How about unstable system?
So, paano determine if it's unstable?
Mm-mm.
So, if yung closed loop, light on the imaginary axis S plane, then the system said to be unstable. If nasa RHP siya, yung right half plane is, or a positive real part complex pole na system is unstable siya.
Mm. Proceed na.
Okay, number 5.
Okay.
Number 5. So,
for the question number 5, will be discussed by Miss Jamay Abukay.
Sa number 5,
wait lang. Ito.
teka.
Nababasa mo?
Ayan. For the system shown below, determine how the closed loop poles are distributed in the complex S-plane. So, ganun pa rin, forward transfer function siya. Naka-polynomial form na yung denominator niya. So, hindi na siya kailangan lang siya, tawag dito. Yung mga coefficients ng S is ilalagay na lang dun sa table ng Rhodes-Hurwitz. Tas dun sa S3, nung minultiply yung 1 times -7 minus 1 times -7 over 1, naging 0 siya. Tapos, nung sa second column naman, 1 times -18 minus 1 times 0 over 1 is -18. So, dito nakita natin na nag-zero yung sa before ng 18. Tapos kapag ka ganun, mapupunta siya sa special case. Ang ginawa doon is based doon sa natin, sa lecture natin. Yung ginawa doon is nagbigay na lang ng value ng smaller value yung e ay yung 0 ginawang epsilon. Tapos
Epsilon.
na lang ng value. Tapos yun na yung isa-substitute doon para hindi na siya mag-zero. Para makuha natin kung ano yung value niya. Tapos yun, ang kinilabasan is eto na yung nasa baba. Yung pababa. Yan. Tapos nagkaroon ng sign change yung simula sa S2. May kulang pala dyan. Dito, yung even dito sa S4. Simula S4. Teka. Hindi mabara. Yung simula sa S4 hanggang S0, even siya. So, nagkaroon siya ng sign change simula S2 hanggang S1. Tapos, ayun. Ay, dalawang beses pala siya magkakaroon ng sign change. Kasi negative 18. Tapos, nag-0. Sign change ba yun? Positive ba yun?
Hindi, negative.
Yung sa S0, di ba S2? Tapos positive yung S2. Positive din kasi yung E. Positive yung S2. Tapos yung S1, negative 18. Tapos yung sa S0, nag-0.
Okay. Same lang.
Nag-change, Nag-change.
Kasi
Negative
para
zero.
nag-negative.
Bale ang magiging hindi ata considered na sign change yun. Kasi positive, negative ang, 'di ba? 0. Positive or negative. So, 1 lang. Tapos, ang magiging poles nun sa right half plane is 1. Tapos, mapupunta yung apat na pole sa left half plane. Ayan. Isang beses lang nag-change. Ganon. Napunta kasi siya sa case ng 0 first column. Ayun lang.
Okay. Bali same process din yung akin eh.
Tama.
Same process din sa akin.
So, guys, question.
Okay.
Okay.
For this number. So, if 0 appears in the first column of a non-zero row in a route array, anong gagawin natin kapag may ganong scenario? Just like for this question. If may 0 siya sa first column.
I-replace na lang sa small positive number. If yun yung case para yung Q, if yung case na yun, para magkaroon ng roots yung Q sa RHP.
Basta smaller number siya. Small.
So, thank you for answering. Is there any more question for this?
Number 5.
Problem.
Okay, sige. So, what are the limitations of Routh-Hurwitz criterion?
Siguro applicable lang siya sa linear system.
Okay.
Hindi siya nagpo-provide ng exact location ng poles ng RHP tsaka LHP. Di ba parang yung sign changes lang, malalaman mo lang kung LHP siya.
Oo. Kasi
Saka yung sa
minsan
RHP.
nga zero eh. Nagagawa ng, may cases kasi, may special cases. Kaya hindi exact talaga yung ano niya, location ng pulse.
Okay. So, it answers.
So is there any more question, guys?
So far, wala.
Okay. So moving on for the questionnaire number 6. So I'll be discussing for this question. So for number 6, so for unity feedback system whose forward transfer function is g of s is equals to k times s plus 6 over s times s plus 1 times s plus 4. So determine the range of k to ensure stability. So yung solution na ginawa namin is that since naka-factored form siya, is dinistribute muna namin yung s plus 1, s plus 4, which is naging polynomial form siya in s cubed plus 5s raised to squared plus 4s. So then after gumawa kami ng route table, then ini-input namin yung 1, 5, 4 plus k, then 6k. So, paano namin nakuha yung equation na 5 times 4 plus k minus 1 times 6k over 5. So, yan. Nakita niyo sa screen. So, k is greater than 0. So, ito, from this equation is in-equate namin siya ng 20 plus 5k minus 6k. So, like terms. So, 5k minus 6k is equals to negative k. So, naging 20 minus k greater than 0. So, yung 20 is greater than k. So, k is less than 20. So, yung range niya is 0, less than k, less than 20. So, yun lang.
Okay, sige.
Okay.
Ako na?
Bale sa akin yung...
Sige.
Sorry.
Go, push.
Sorry. Di ba hinahanap yung case stability yung sa number 6?
Range.
Range. Okay.
Range.
Bale,
range.
yun nga, same. Since given naman yung transfer function na k, s plus 6, over s plus 1, s plus 4. So, sinolve ko lang yung transfer function. And nag-come up ako sa 1 plus k s plus 6 over s cubed plus 5s squared plus 4s. Ngayon, simplifying yung nakuha naming unang sagot. Nagkaroon kami ng s cubed plus 5s. As you can see dun sa screen na tapos plus 4s plus k s plus 6 over s cubed plus 5s squared. Then, going sa table ng Hurwitz ba yun? So, pinakamataas na higher power is s cubed, s squared, s1, s0, pababa. Tapos, plugging yung mga nakuwang values after namin i-simplify. We have a s is equals to 1, a s is equals to 5, 4 plus k, a2, 4 plus k, a3, 6 plus k. Tapos, bale, solving it by cross-multiplying both sides divided by 5. We will be having this answer sa S1, 5, 4 plus k minus 1 times 6 plus k over 5. Same goes sa process ni Mr. Navarro. Tapos, yun din yung ginawa ko sa solving ng case stability. So, having the value of k, k and 0, 20 plus 5k minus 6k. Solving for it, we will end up with 20. So, yun yung magiging stability ng 0. 0 is less than k. Sorry. Tama no? Less than k. 0 is less than k, less than 20. Tama. Okay. Yan.
Okay.
So, yun yung process na.
So, sa
So
akin,
guys, okay, go Mr.
okay. Ako ba muna?
Yes.
Okay. Sige. So, yung ginawa kong process is, ayun nga, yung kukunin mo muna yung transfer function. So, k times s plus 6 over s plus 1 times s plus 4. So, i-distribute mo muna yung s plus 1 tsaka s plus 4. So, we come up with, so, k times s plus 6 all over s cubed plus 5s squared plus 4s. So, simplify lang. So, ang lalabas dyan is s cubed plus 5s squared plus 4s plus ks plus 6k is equal to 0. So, after makuha yung equation, gagawa na tayo ng table ng route Hurwitz. So, we have 4 poles. So, yung highest is yung s cubed. So, ilagay mo muna yung poles niya. So, s cubed, s squared. So, s to the first, s0. Then, input mo lang yung mga data. Then, after nun, kukunin mo yung determinants by using the matrix. So, ganun lang din. Cross multiplication. 1 times 6k minus 4 plus k times 5. So, ganun lang. Cross multiplication. So, after that, kukunin na natin yung range ng k. So, paano namin nakuha tong 20 plus 5k minus 6k is dito lang yon. So, i-distribute lang to. Yung 5 times 4, so 20. So, yon. So, yung 5 times k, so yung 5k, tapos ito lang, 6k, negative 1 times 6k. So, yun, greater than 0. So, simplify lang to. 5 minus 6, so magiging negative 1. Hindi na kailangan lagay ng 1. So, yun lang. So, after nun, transpose mo lang yung k. Makukuha mo is 20 greater than k. So, ito na, simplify namin. 0 is less than k less than 20.
Tama.
So, thank you for answering number 6. So, moving on, let's proceed to questionnaire number 7. So, Ms. Abukay. Ms. Abukay.
Yung sa number 7, yung nagawa ko lang kasi dyan, yung sa route table. Ay, hindi ko pala natapos. Kasi, hindi ko alam kung paano itutuloy. Teka lang.
Ako bali, nag-stop ako kasi di na ako umabot sa route table eh. Nag-stop ako sa pag-simplify na medyo
Yan sa
na-overwhelm ako.
transfer function lang.
Sa akin sa transfer function. Buti nga si Miss Abukay umabot sa route table. Ako
Route
hindi ako
table.
umabot.
Hindi ko natapos.
Overwhelmed din ako sa haba nung nung i-simplify ko. Pero siguro bago ipasa yung papel.
Kay Mr. Labio, meron ba tayong sagot dyan?
So, number 7. Wala. Tanong meron, sagot wala.
Yan, so moving on. So since wala tayong answer for number 7, so let's proceed for the number 8. So this question will be discussed by Mr. Rojas.
Well,
Nakikita ba?
so for the system shown below, find the value of k that will make the system oscillate, then find the frequency of oscillation. So nakikita niyo sa system, we have k. Sorry, paki-zoom nga Mr. Labio. Okay. So we have k, transfer function of 1 over s plus 4, s plus 6, and s.
Okay.
Okay. So first, ang ginawa ko is getting the Sorry. Writing the closed loop transfer function since given naman. Solving for the Laplace. Okay, we will end up having, okay, so pag sinimplify kasi natin yung formula, since ang given formula is K1 over S plus 4S plus 6 and S, combining it since TS is over RS, combining it to have one transfer function, we will end up having K over S plus 4, S plus 6, S plus K. Dun sa sagot namin, nakikita naman na simple ano lang naman simple combining of given systems. So solving for the Laplace of the transfer function, we will end up having K over S cubed plus 10S squared plus 25S plus K. Okay, so the characteristic equation, we will have 1 plus CS HS is equals to 0. The equation that we'll have is S cubed plus 10S plus 25S plus K, which is equal to 0. Ito yung equation na gagamitin natin sa Roth table. Okay, so yung Roth table is, since nabanggit ko ng higher power S cubed, we will write it in the Roth table na S cubed, S squared, S1, S0. Tapos A ko is 1, A2 is 25, 10, tsaka K, A3, and so on and so forth. Solving it by 1 times K, 10 times 25 over 10, we will have 250 minus K over 10. And solving it further, we will end up having K. Tapos yung mga natitirang values na lang sa Roth table, lalagay na lang natin 0. So, 0 will equate in the term of coefficient. Since yun yung margins, yun yung nagpapakita na na stable yung system. So 250 minus K over 10 is equals to 0. K will be 250. Solving for 250, yung formula natin na 6S squared plus plus K is equals to 0. 6S squared. Take note, 6S squared plus K is equals to 0. Okay, so since yung K natin is 250, substituting K to 250, so magiging 5 yung final answer. Then pala yun yung magiging final answer. 5 yung frequency oscillation. Yun sa answer.
So for number 8, pwede pa ulit nung
Tanong?
yung slide. Yung sa answer. And yung first part.
Wait lang.
So for number 8, for the system shown below, find the value of K that will make the system oscillate, then find the frequency of oscillation. So given na may tayo, then nakaparallel, which is yung G mo dyan is yung 1 over S times S plus 4 times S plus 6. So, ang unang gagawin is yung nakaparallel part. So, G is over 1 plus GH. So, by substituting all the values ng G, so we'll end up having 1 over S plus 4 times S plus 6. Then, since na 1 plus GH, so substitute din ulit natin yung G. Then, yan makikita natin sa screen. Then, yung H, yung value niya is S. So, by solving it, ang lalabas nating answer is 1 over S times S plus 4 times S plus 6 plus 5. But next slide po. Next slide. So, given na lumiit na simplify na natin yung yung system, magkakaroon lang tayo ng K papunta sa GH na kanina sinimplify natin. So, K, pumultiply natin dun sa 1 over S times S plus 4, S plus 6 plus S plus 5. So magkakaroon ulit tayo ng ganitong equation, yung K times yung na-simplify natin kanina plus K over 1 plus S times S plus 4 times S plus 6 plus 5. So by solving it, so we will arrive by this equation. K is equals to S times S plus 4, S plus 6 plus K plus 6. So since naka-factored form siya, gagawin natin siya polynomial form, magiging S cubed plus 10S squared plus 25S plus K. So, nagawa na tayong round table after nun, since mayroon na tayong values for sa denominator. So, S cubed is yung 1. Then, input lang natin yung value dun sa round table, 10, 25, then plus K. So, by cross multiplication, so 10 times 25 minus 1 times K over 10, ang magiging value niya is 250 minus K over 10. Then, given dun sa equation na yon, K is greater than 0, then yung value natin kanina na equation, 250 minus K greater than 0, magiging 250 is greater than K, then ang frequency oscillation natin is K is less than 250.
Kinaltek ko din. Caltech din. Kinaltek. Madali lang din naman makuha yung K pag Caltech lang.
Okay, so may question ba?
Siguro bago na lang magtapos tong presentation, per member, advantage na lang ng Routh-Hurwitz criterion since ito naman yung pinag-uusapan natin sa presentation. Kayo guys, anong masasabi nyo na advantages ng Routh-Hurwitz criterion? Mr. Navarro?
Routh-Hurwitz criterion is one of the advantage of Routh-Hurwitz criterion is that pwede mo siyang, yung system, pwede mo makuha yung stability niya without solving the equation. Then, madidetermine mo kung RHP siya or LHP, yung right half plate or left half plate.
Ako para sa akin yung we can determine yung sa case stability. For me. Kaya yun yung advantage niya.
So, guys, are there any more questions for question number 8?
Number 8.
Number 8.
So, paano natin ma-determine yung LHP?
So, yung LHP, ma-determine natin sa sign change. Sign changes. Kung ilan yung sign change is equals to, I'm sorry, RHP, di ba?
LHP. LHP. Left.
Since pag even, doon natin malaman kunwari yung RHP is equal to 2, then yung natitirang values is LHP na. So, doon, mas mabilis ma-determine siya kapag may sign changes. Then, yung matitirang values, doon natin malaman LHP.
Tama.